Good morning. My name is Bruno Zumbo at the University of British Columbia. I'm sorry I'm not able to join you today in Florence, a lovely city, and I've spent many lovely time there. Unfortunately, I'm not able to travel at the moment, but I'm thrilled that I've been able to join you through this video medium. Get to see a little bit about myself there in this slide, and in particular, I want to take a moment to thank a few individuals, and to thank Professor Anna Maria Di Fabio at the University of Florence, who in her role as president of the Scientific Committee and Program International for the conference of the International Conference of Applied Psychology, and also as co-vice president of the ICAP. In that role, Professor Di Fabio was kind enough to invite me to organize this symposium that aligns with the invitation to deliver a keynote address as well at the conference. The symposium came together after the invitation with my colleague, Professor Smita Tagliabue and Dr. Michela Zambelli, who I met with and discussed, and we've been having some opportunity to share some of the work we've been doing and work really to advance some approaches that move beyond the static and sort of in vitro models of psychological traits and constructs. And in vivo is a concept I've been playing with for a few years. And this move is really to move psychological measurement into a more responsive, contextualized, and dynamic science. So the focus today and the accompanying paper that I have is psychometric methods, and particularly classical test theory, which for much of the past 125 years has been the dominant framework for test construction, psychometric analysis, the use of technology for test delivery in the health, educational, psychological, and social science research, as well as professional practice, excluding the large-scale companies that deliver tests all over the world. More in a research setting and in a practice setting, classical test theory has been very active. This work, the work reported herein, emerges from a series of recent papers of mine that develop what I've called an operator theoretic formulation of test theory. Here I'm leaning on my background as a mathematician, and I presented, originally began work with Donald Zimmerman, Professor Donald Zimmerman, on this Hilbert space measure theoretic, operator theoretic approach to test theory, gone back and basically reconceptualized what Lord and Novick and many of the others have done. In that formulation, the true score is defined as a conditional expectation rather than hypothetical repetition. And that is an important distinction that's going to come up later. Hopefully it'll be clearer. So Lord and Novick, in their classic 1968 volume, introduced the widely adopted classical test theory mathematical and statistical model. We'll see later that applications of their view is driven by a semantic model based on the thought of experiment, of an idealized repeated testing. And this provides the interpretive description of the mathematical or syntactic model of classical test theory. It's usually described as serving an expository or pedagogical purpose, but otherwise it's inconsequential. So this semantic model, so there's all of the mathematical structure, and that's sometimes referred to as the syntactic model. That if one is going to, and those are usually symbols, there's a logic mathematical system there that's created. A lot of the work done by Lord Novick is based on advanced probability theory. and the definition of random variables that are in fact have certain properties. But it comes with an idealized sort of semantic model. Let's give some interpretation. Let's put some meaning to these words, to these symbols, more than just as mathematical symbols and objects themselves. As a mathematician, the symbolic element is sufficient. But even when I take it and I want to conceptualize, so what is a true score? T, the symbol, a very complex idea. Well, this idealized repeated testing experiment is introduced, and but otherwise it's sort of considered to be inconsequential to the development and use of CTT, meaning that the idealized model often is portrayed as, oh, it's got expository pedagogical purposes, but doesn't affect otherwise. We'll see whether that holds true in our case. So in this paper, I argue that the repeated testing framework, as described by Lord Novick, embodies an implicit ontology of measurement. Its assumptions extend well beyond statistical convenience, and they shape how psychometricians conceptualize constructs, score variation, measurement goals, etc. A little foreshadowing, the framework assumes stable constructs, incorporates systematic reproducible influences into the true score, and relegates construct theory to considerations external to formal mathematics. In reality, it also specifies what kind of entities are presumed to exist. So the framework assumes that the individual test taker, survey respondent, possesses a fixed quantity that persists unchanged across all hypothetical repetitions of what we're going to call this, the repeated testing experiment. So measurement as a process does not construct or explain this quantity. It merely samples from a distribution centered on it. Consequently, the true score becomes an ontological primitive. It's assumed to exist independently of any substantive explanation of how responses are generated. Well, if we take this repeated testing, sort of this semantic model, the basic idea behind it is that it posits a hypothetical test or test questions, one or more test questions. An individual completes the test, asks a particular question: what's your current opinion regarding the political climate in Canada? And there'd be a response of some sort. Then the person's memory is wiped clear; it's erased, and they're again given the same instrument. And of course, because their memory is erased, etc., hypothetically, this is now de novo. You see it clear of any past experience, and you respond again. And this goes on over and over and over, and hypothetically to infinity or to some very large number. And now you have a distribution for an individual, distribution of score results, right, or survey responses. So the framework assumes that the individual possesses a fixed quantity that persists unchanged across all the hypothetical repetitions. You can see this. So this is sort of a very, it's not meant to actually reflect anything, anything close to what happening on an actual testing context. The only place where it's almost taking playfully is in the movie series Men in Black, where at the end of any incident they wipe their memory clean, and with this little gadget that's what I imagine now when I discuss this, and when I tell students and work with grad students, postdocs, etc. I say it's kind of like this Men in Black kind of thing. You wipe the memory clean, And people again go on and they complete it, and every time the score is produced. So measurement here does not construct or explain this quantity that the individual has. Consequently, the true score becomes this ontological primitive, existing independently of any substantive explanation. So that becomes important, because now what comes of this is that you have we're now directed to look at stable constructs. And it also assumes to incorporate systematic, reproducible influences into the true score. And it relegates construct theory to considerations external to the formal mathematics. Let me say a few more words. The derivation in Lord Novick, mostly in chapter 2 of their book, starts as many derivations of this sort will begin at the individual test taker. And then it sort of pulls itself up. You have each individual test taker, and then you sort of pull this all up into a group-based average. That's actually a very tremendous mathematical shift that occurs, and logical shift. And the semantic model, one of its intentions is to help us do this. I'm struck by it a little bit. The approach that I've developed, you'll learn about separately when you read the paper and some of my recent papers. I don't begin from that manner. I don't have to. Using operator theory, measure theoretic approaches. But for every individual, the definition is that you have a true score is the expected value of x, there's a sequence of x's, for an individual test taker, contains only observed scores and their probability distribution. So that the true score here is just defined as the expected value, that's your scripted E there, for every individual they have a distribution like this and their true score, and you get variation not within but across individuals. So neither intelligence, depression, anxiety, quality of life, nor any other psychological construct appears explicitly in the mathematical model. The construct motivates development of the test, but once the probability model is established, it disappears from the theory. This disappearance of the construct is a remarkable feature. The mathematics concerns only observed scores rather than the mechanisms that generated them. The approach that's more modern, more contemporary, that's been developed, this operator approach that Don Zimmerman and myself, Rolf Steyer and his group has been involved with as well in Germany. It actually doesn't have that. The construct is part of it. But in Lord Novick's, the mathematics only concerns the observed score. The thought experiment, this repeated testing thought experiment, the semantic model, embeds three major commitments. To remind us, constructs are treated as stable properties rather than dynamic processes. Measurement is conceived as repeated observation of an already existing quantity. So if you're measuring someone's level of extroversion, that's an already existing quantity, and it's stable. Explanation becomes unnecessary for defining the true score. Why does someone particularly, actually it's purely descriptive, there is no explanation. And that these assumptions have shaped classical psychometric thinking for nearly a century. My concluding slide, and then I urge you to take a look at the paper. The repeated testing thought experiment has played an indispensable role in the development of classical test theory. Nevertheless, it also established implicit ontology. It continues to shape psychometric reasoning. And today's symposium is really about shaking up that psychometric reasoning. Well, I'm claiming here, I'm positing here that the semantic model, this repeated testing semantic model with the memory erasure between tests, has a big role in where we are today and why we are still working hard to bring these alternative models away from the notion of a stable construct, repeated testing of an already existing quantity. And there's no need for explanation, purely descriptive. By defining the true score through hypothetical repeated observation, this semantic model privileges stability over explanation, descriptive partitioning over causal understanding, and probability distributions over theories of response generation. I'll leave you with that. Hopefully I've enticed you enough with a little bit of a taste here to say that most recently it's actually this line of work on an alternative foundation, operator theoretic. It began in 1975 in a paper by Donald Zimmerman in Psychometrica. Fortunately, a paper that is, Psychometrica is never an easy read, and that paper is itself never an easy read. Throughout the whole paper, that's 75, I started working with Donald in the mid to late 1980s, sort of a wandering, lost mathematician looking for a place, and I found Zimmerman's work, and Zimmerman absolutely fascinating, and to work with him. We worked together for the next nearly 25 years, and one of the things we did work on along the way is developing this further, and then I picked up the ball again most recently with a series of papers on it. In that alternative formulation, this operator theoretic, measure theoretic formulation, Hilbert spaces, it makes explicit that measurement depends upon a theory of the information relevant to the construct. It actually forces you to consider construct relevant versus construct irrelevant variance, is one way to think about it. There is no repeated testing kind of semantic model that goes with it. It's a transition to what's conditional expectation. And it's a broader transition in psychometrics from descriptive empiricism towards explanatory empiricism. That's a link to the paper. I encourage you to get a copy. I'd love to hear what you're thinking. And I really wish my colleagues were there, everyone in the room, buon giornata, and I hope you're going to have a lovely day in Florence. Thank you very much.